At higher, you're expected to be able to solve equations with two trig functions. So this combines some trig equations from National 5 and some of your quadratic stuff as well for National 5, and that you have to be able to factorise to solve the equation, but then you also have to be able to solve a trig equation. So for this first example, it wants us to solve the equation 2 cos squared x plus cos x minus 1 equals 0. Now, depending on how you've been shown how to do this, you might find that the way that I do it varies slightly. I will try to cover it for everyone. So the way that I would recommend starting off thinking about this is that if you went with a quadratic, you would have 2x squared plus x minus 1 equals 0. So this expression here and this expression here are the same thing. It's just that instead of writing cos x, I've replaced cos x with x on both chances. So cos squared x equals x squared and cos x is just x. Now, if you were asked to solve that, you would then have to split it into two brackets. I could split up my 2x and my x, split up my 1 and my 1, and then I'm looking to make a positive 1 using these 1s and the 2 as well. So it would be a plus 2x and a minus 1. Obviously, you may have a different method for factorising, but for me, that's how I would figure it out. So that really means that what I've got is replacing my x with cos x. I've got 2 cos x minus 1, and I've got cos x plus 1. And that's equal to 0. That's quite a nice way to do it until you are confident with doing it with the cos, the sine, or whatever the function is that you've got. You can use that method, or you can go straight into just factorising it. So down here, I could split up the 2 cos squared x into 2 cos x and cos x. And that's equal to 1. Split the 1 into 1 and 1. I need to use this 2 cos x times by 1 and this cos x times by 1 to make a plus cos x. So it must be a plus 2 cos x when I multiply it minus a cos x. So you can compare it to a quadratic function, solve that, and then put the cos, the sine, the tan, whatever it is back in, or you can just go straight to that. So either way, when you get to this point here, you now have two different equations that you're working with. So we've got that 2 cos x minus 1 is equal to 0, or cos x plus 1 is equal to 0. Now, why we've got that is because one of these two things has to be equal to 0 for the full thing to equal 0. So you need to times something by 0 to get 0. So one of them must be equal to 0. So that means that cos x, if I rearrange this by adding 1 onto both sides and divide both sides by 2, cos x is equal to a half. Or I've got that cos x is equal to negative 1. So the minute you've got your cos x, tan x or sin x line, you can use your cast diagram. In questions like this, we are going to have two cast diagrams because essentially what we've ended up with is two trig equations. So over here we've got cos x is equal to a half. That's a positive cos x, so I'm ticking A and C. And over here we've got that cos x is equal to negative 1, so we're ticking where it's negative. And we've got S and T. Keep going to get x on its own. So over on the left hand side, x is going to be equal to cos inverse of a half. Cos inverse of a half gives us 60. So that's our calculator answer. That's our A quadrant. This could show up in a non-calculator question as well because that was an exact value. To find our answer in our C quadrant, we're doing 360 minus that 60 degrees. So x is equal to 60 and x is equal to 300. On the right hand side, we've got that cos x is equal to negative 1. Now, remember, you don't put negatives into your calculator. So x is going to be equal to cos inverse of 1. Now, there is various different ways that you can do this. So you could have just skipped that step and recognised that cos x equal to negative 1 is equal to negative 1 at 180 degrees. It's at its lowest point after 180 degrees. Or for using your cast diagram, which is the way that I would do it, cos inverse of 1 is equal to 0. Looking at our cast diagram, to find our answers, we would have to do 180 minus 0 and 180 plus 0 Either way, you're going to end up with x is equal to 180. And then just to make my final answer nice and clear, because there's lots going on there, we're having the two equations, I'm going to rewrite my answers down here. X is equal to 60. I'm going to go in ascending order, and I'm going to put my 180 and then my 300. Quick double check on my restriction. We wanted answers between 0 and 360. All these answers are, so that's my final answer. Moving on to this next example, so this one's a little bit trickier. If we were to try and factorise this, or if we were to try and replace this to make it look like a quadratic, it would be very difficult because we have cos squared x and we have a sin x if we've got two different functions. The trick that we would use to manipulate this is to use our trig identities, or as you'll see in a few lessons' time, we could use some of the formulas that we've learnt at higher. So for this one, we know that cos squared x can be replaced at National 5, and as you've seen a few weeks back at higher, we should know the expansion, or the trig identity, sorry, that cos squared x plus sin squared x is equal to 1. That means that cos squared x's and sin squared x's can be manipulated. So in this case, cos squared x is going to be equal to 1 minus sin squared x. When we replace that, we're going to end up with a sin squared x, and we'll keep that sin x, and at that point we can start to manipulate it and then factorise it. So I'm going to replace this cos squared x with 1 minus sin squared x plus sin x is equal to 1. I'm going to rearrange this just to get it slightly nicer and to deal with my negatives. So again, you can use any method you want, do this in any form that you want, just as long as we end up with the same answers. It doesn't matter how we got there. So I'm going to change this to a positive sin squared x minus sin x minus 1 is equal to negative 1, because I've worked my way through it by times and everything through by negative 1. To factorise, remember it has to be equal to 0, so I'm going to add 1 on to both sides, and I get sin squared x minus sin x. Negative 1 plus 1 is going to give me 0, so it's just equal to 0. At that point, I can factorise it. So unlike the first example, we don't have a trinomial, we have a common factor in this one, so we can take out a sin x. That's going to leave us with sin x minus 1 in our brackets, and that's equal to 0. So that means that sin x is equal to 0, or sin x is equal to 1. Now in that last example, I had mentioned that you didn't have to use your cast diagram. That will happen on occasions where you can just use your graph. So this would be a perfect example of when you can use your graph. So if I was to draw the graph of sin x, there's my x-axis, there's my y-axis. The graph of sine goes up, down, and back up. So it ends at 360, crosses through at 180, maximum at 90 degrees, and minimum at 270 degrees. Remember, it goes up to 1 and down to negative 1. So we're interested in when sin x is equal to 0. Sin x is equal to 0 here. It's equal to 0 here, and it's equal to 0 here. So when sin x is equal to 0, x is equal to 0, 180, and 360. On this other side, where we've got sin x is equal to 1, sin x is equal to 1 up here. So x is equal to 90 degrees in that case. So I'm going to put all these answers in one list, do them in ascending order. We've got 0, 90, 180, and 360 degrees. And that's my final answer for this one.